Hello students, welcome back to the chapter called LPP. In this module, we will see one more question on how to formulate LPP. So let's start with our question. The question says that there are two kinds of foods, that are food A and food B, which are considered to form a weekly diet. Now it is given minimum requirement of fats, carbohydrates and proteins for a person as 17, 28 and 14 units respectively. Now 1 kg of food A has 5 units of fats, 12 units of carbohydrates and 7 units of proteins. Whereas it is given that 1 kg of food B has 7 units of fats, 15 units of carbohydrates and 9 units of protein. Now the price of food A is rupees 5 per kg, whereas price of food B is given as rupees 7 per kg. With all this information, we need to formulate LPP in order to minimize the cost of food. So in this question, to determine exactly how much amount of food A and food B to be consumed. So that will be a decision variable. So let's start with our solution. First step would be deciding decision variables. That is, assume that X kg of food A and Y kg of food B are consumed by the person. Now the price of 1 kg of food A is given as rupees 5. So obviously price of X such units of food A will be 5 multiplied by X rupees. Similarly, price of 1 kg of food B is given as rupees 7. So price of Y kg of food B is given by 7y. So total price or total cost for food A and food B together will be addition of these two, that is 5x plus 7y rupees, and let's denote this by capital letter Z. And this is, students, our required objective function. So our objective function will be minimize Z equal to 5x plus 7y. Why minimize? Because it is total cost. So let's proceed to next step, that is calculating constraints. Always remember, students, whenever we'll be given a problem like this, first thing we will do to calculate constraints is write all this information in tabular form. Let's see how to do that. So we'll prepare a table. In this table, first row will contain food A, food B and minimum requirement, and column will contain corresponding contents of fats, carbohydrates and proteins in each kind of food. Now it is given that 5 units of fats are there in 1 kg of food A. Similarly, 1 kg of food A contains 12 units of carbohydrates and 7 units of proteins. Again, it is given that 1 kg of food B contains 7 units of fats, 15 units of carbohydrates and 9 units of proteins. And the last column we'll prepare is of minimum requirement of all these contents, that is fats, carbohydrates and protein, which are given as 17, 28 and 14. So with the help of this table, now we are going to calculate our constraints. Now we know that 1 kg of food A contains 5 units of fats. So obviously X kg of food A will contain 5 multiplied by X units of fats. And again 1 kg of food B contains 7 units of fats. So obviously Y kg of food B will contain 7 multiplied by Y units of fats. So our first constraint